Hello everyone. This is a video lecture for Business Calculus, Math 1325, Section 13.2, Applications in Business and Economics. I actually don't have any new formulas for you here yet, but I'm going to show them as we come up to the problems that we need to. But as of now, we're just going to do whatever they say to do, and it's a lot of word problems. So the main point here is to see what I'm doing on them so that you can replicate that on your homework because word problems are kind of confusing sometimes. So 13.2.11, we're just going to do some of these problems together and I'll point out certain things. I believe that this one just has this integral and it says do it, which is very nice because there's nothing to be done. We can just do this all in Desmos. And at this point in the class, at this point with what we've been learning, you could do that by hand, sure. But I think that doing it in Desmos is going to be quicker for you. There we go. And we're done with that problem. That was it. 192.576. Good enough. Next problem. So some of these have a lot more wordy words with them, and this is one of them, I guess. It has a probability function. It might be called a probability density function, but regardless, it's for probability of failing, I think is what it was, like some kind of product that was failing. I don't write down all the specifics of the problem because it doesn't really matter so much. What matters is kind of like how you're going to do the math side of things. So I'm just writing down kind of what they have and how we're going to approach this. So T is in months, and that is something that really threw me off. I was trying to do this in years, and it was totally wrong. So T is in months. So keep that around. This is a probability. And so part A, it says, what is the probability of failing within the first year? So the probability of failing in the first year. And again, we're talking first year. We're talking months. And so that's going to be 0 to 12. So integral 0 to 12 of this function. We're wanting to add up all these probabilities, essentially, and get an answer. I have a weird answer here on mine. I think it was because I was doing a 1 instead of a 12, but let's just see what happens here in Desmos. E, T, DT. Yep, that's it. We're done. 114419. Sweet. Okay. Part B, it says, what's the probability of failing in the second year? So what does it mean by second year is that it'll be 12 all the way to 24. We're not wanting to include the previous year. It doesn't say during the first 2 years. It says in the second year. So very specifically. So that's why we're going to go 12 to 24. And there's my answer. Good. Okay, so those are probabilities of something failing. Around 11% the first year, 10% the next year, so on and so forth, until you add them all up and it eventually kind of be 100% probably. Not 100%, it would be like 99.999, but there you go. But we're not going to investigate that much more. So this is going to require a really weird formula, which I don't think they even give you until you get it wrong, and that's why I do all this kind of stuff beforehand. So we got 4.75% interest. And when it's compounded continuously. Okay, so a lot of this we kind of already know. For 4 years. Okay, and it says it gives me an f of t, which is very different than everything else we have here. And they say, what's the future value? Okay. So this, let me write down the formula for future value, because otherwise we're just going to be lost. So ERT times, and then we're going to do integral from 0 to t. T like is time, of course. And then I got my f of t times e to the negative rt dt. So that's the future value formula. I have to say that it looks really confusing, but once you start putting it in, it's not too bad. I'm also not a business person. First, I'm a math person, so future value and a little bit of these things are a little weird to me. I'm not going to begin to be perfectly explaining all this stuff to you, but I can say that we have some kind of interest going on, and this function is growing. No, it's decaying over time. So, anyways, you just plug it in, and so here we go. This is what it would look like. E to the 0.0475, and then time was for 4 years. Integral 0 to 4 of this function. So I'm just going to like literally copy it in t, and then times e. Oh, whoa! I did one tiny mistake up here. One tiny mistake. Hold on. I want to fix it right here. Oh, come on. You're not going to let me erase? Okay. Let me tell you then. This is a little t. It's not a cap t. And that's going to be very important because cap t is like the total years, but the little t is a variable that we have to integrate and all that kind of stuff, okay? So that's a little t. I thought it looked a little weird to kind of like have two constants, and that's totally wrong. So watch out for that, okay? I did make a small mistake on my formula, but I'm correcting it here. Okay, let's put this whole thing into Desmos. Obviously, I don't want to be sitting here all day trying to figure out what's going on. Nobody wants to do that. So Desmos is very picky about its powers, so you have to use these parentheses to get what you want. The f of t, as far as I know, is like an amount that you're investing over time and like you're putting into the account. But then that account is also growing. So this is kind of like compound interest, but a little bit more advanced. Again, I'm not going to pretend to know every little specific about future value. I can tell you this is the formula. This is how you're going to do the problem, and we're going to get through it, okay? So there you go. And this is dollars. So there's your future value one. Let's do one more. There's another future value problem. Hopefully you're learning about these other things in other classes. They're not relying on your math teacher to teach you that business-related stuff. So for 4 years, we got 5% income stream, a 5% income stream. Okay. And there are two choices that we can choose from in this problem. So we got f of t is equal to the 18,000. And then we got g of t is equal to 17,000 e to the 0.03 t, which is growing. It says find both future values and which one's better. Okay. So we can either have a constant, and it says 5% income stream, so we have a constant value, or it's going to be growing in an account, I guess. So how do we go and do this? I'm just going to show you. It's not hard. We got E.05 from the 5%, and we're going to multiply it by the 4 for the 4 years. And that's in the front, integral 0 to 4 of, and then I'm going to put this 18,000 in there. And multiply it by e to the negative 0.05, again from 5%, t dt, and we're going to get a number. My g is going to be the other guy. That's supposed to be a little g. Now it's a capital G because you integrated. So now I've got e 0.05 times 4, integral 0 to 4 of 17,000 e to the 0.03t, all this times e to the 0.05t dt. And then we're going to find a number. Oh, I messed up something along the way. No, I didn't. No, I'm good. It's just so many E's and powers. It's just like, man, there's so much going on here. And you can see that's why I'm doing Desmos. We could do this by hand, but like, why? Why would we actually want to do this by hand at all? It just wouldn't. It's at this point in the class, you're not wanting to do that. I don't want you to do that. So here's my first one: is 79704.99. So that would be 79705, I guess, if they're wanting to round. And then this guy, we can slightly adjust it by just changing this number to a function. At least I thought we could. Okay, there we go. Very, very picky with their numbers 79820, essentially. And so which one's better? This one's better right here by just a little bit. So that's the better future value. Again, those are in dollars. So, okay. This is the last question, and it needs also a special formula. So let me write it down first, and then we'll talk about it. So I've got price. I think that's P for price is equal to D of X. So it's, is that demand? Anyways, I have 500 minus 0.05x. And then they have P hat is equal to $150. That's like an average price. And it says, what is the surplus? Okay, so we're going to need a special formula for this. I have to get it wrong 3 times just to kind of see what my MATLAB's wanting. So 0 to x bar of d of x minus p bar dx is equal to what they want. So that's your formula. Obviously, that's so clear. It's okay. It's not that bad, but it's just kind of weird. So p bar, or I'm sorry, x bar is found when p and p prime are equal. So p equals p prime. I'm sorry, prime. I say prime. It's a bar. So p equals p bar. That's when you'll find what your x bar is. So we have to do a little bit of math first. Basically, they're saying when are these two equal to one another, and that would be my average. So 500 minus 0.05x is equal to 150, and I need to solve for x, and that would be my x bar. So I'm going to move this over and move that over. I essentially have 500 minus 150 is equal to 0.05 x, divide, and let me find out what that would be. 7,000. So basically x bar is equal to 7,000, and that's what I'm going to start to integrate with here in just a second. So 0 to 7,000 of my 500 minus 0.05x, and then minus the 150 dx. I'm just plugging it into this formula right here. See, 150, this thing goes here, no problem. Calculator, and we're done. Again, all of this, I recommend it in Desmos. Oops. Okay. 500 minus the 0.05x minus the 150. And I'm using an x, so there you go. We got it. 1,225,000. There you go. So 1 million, da 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 da. Again, this is dollars. That's all for this section. That's all I got. So thank you very much, and have a great day.